Dear children, welcome back to the class. We have started this beautiful chapter called alternating current, and we are here at the fourth lecture. Now, already we talked about this series RLC circuit, no? Series RLC, or you can use LCR. Okay, whichever word you want, you can use series RLC circuit. How it looks like R, and this is going to be L, and this is going to be C. R, L, and C. And this is connected to AC source. Okay, so here is the AC source, and this source is represented as V is equal to V naught sine omega t, right? Then I am going to have something called Z. Z is equal to under root R square plus XL minus XC whole square, and XL is equal to omega L, that is equal to 2 pi FL. Everybody knows that. XC is equal to 1 by omega C, and that is equal to 1 by 2 pi FC. That is also known to you. Now, voltage drop here is VR, and voltage drop here is VL, and voltage drop here is VC. Okay. What is, I mean, here the current is I naught. What is the voltage drop in resistance? That is equal to I naught into R. What is the voltage drop in inductor? That is I naught into XL. What is the voltage drop in capacitor? That is equal to I naught into X. Together, all these together form V naught. Okay. I mean, you have seen in, in a DC also, no? For example, these are two resistors. If I'm giving here, for example, 12 volt, I'm giving 12 volt means here if 8 volt is, it is getting dropped means here how many volts will drop? 4 volts will drop, no? So whatever 12 volt is here, the same 12 volt has to distribute itself into 8 volt and 4 volt, right? So this 8 plus 4 is equal to, it becomes 12. We know that. Similarly, whatever this VR, VL, and VC is there, together, all of this together, okay, whatever these things are there, together it has to become equal to V naught. That's what I was trying to say. Now, I asked you yesterday, how to prove, how the question will be asked. They will ask you, derive the expression for, this is 5-mark question, 5-mark derivation. Derive the expression for impedance. Derive the expression for impedance of series RLC circuit. Series RLC circuit. Okay. They will ask you to derive the expression for impedance of series RLC circuit. How to do it? Let us see. Okay. First of all, for this you draw this series RLC circuit. This is R. Okay. This is L, and this is C. You draw this circuit. Okay. Already I have given you idea how to do it, and you draw this. AC source, which is V is equal to V naught sine omega t. All right. This is R, this is L, and this is C. And here the voltage drop will be VR, and here the current is I naught. Here the voltage drop is VL, and here the voltage drop is VC. Everybody knows that. And what is the formula for VR? Just now I have told you, that is I naught into R. What is the formula for VL? That is equal to I naught into XL. What is the formula for VC? That is equal to I naught into XC. Now do one thing, dear children. Yesterday I have talked about leading and lagging. For example, this one, no? Here I will take current. Okay, this is the current which is like I naught. Okay, if this is the I naught, don't you think along with this only VR will be there? VR is there along with this only, no? So for example, if you consider this point as O, okay, so this VR, this is like vector, no? One vector VR. Okay, voltage drop in resistance, it is along with, and I know that. And VL will be above, right? How will be VL, dear children? VL will be above, no? Why? Because it leads current by 90 degree. Yesterday I have told you. VL means voltage drop in inductor. It is leading the current by 90 degree, no? So that's why VL has to go forward. Now, how about VC? VC has to come down, right? Why VC has to come down? Because current is leading in capacitor. So that's why whatever this VC is there, voltage drop in capacitor, that will be coming down. I hope these things are very, very clear in your mind. Okay. See, look at this. I mean, this is whatever, I mean, thing I'm showing here, horizontal line, that is I naught. Okay. Along with that, only VR is there. And 90-degree forward VL is there, and 90-degree backward VC is there. Okay. Fine. So, yesterday I have explained this. And let us assume, okay. Let us assume, what to assume? Let us assume let us assume VL is greater than VC, for example. Okay, let us assume that. I'm not saying, I mean, exactly it will be there. Let us assume that. You may take VC is greater than VL also. You can see here, no? So look at this length. This length is more, no, dear children? This VL is more. All right, so whatever this length is there, VL, it is more, and this VL, whatever it is there, this I mean, this VC is a little smaller length, no? Look at this is smaller length. So that's why I have taken it as VL is greater than VC. You can take reverse also, no issues. Okay, so now whenever VL, I mean, you know that, no? For example, on this point we have 10 Newton force and we have 2 Newton force means 2 Newton force means how the force will be there in this direction. How many Newtons? 8 Newton, no? So similarly here also, instead of this VL and VC, I mean, instead of using both of them, I'll take one vector here, which is like VL minus VC. Look at this. See this vector, whatever I'm drawing here, this complete vector from O to this VL, this point, this complete is like a VL. I know that. And I mean, this is like complete VC. Okay, from here to here, this is VC. Okay, so after that, whatever I'm drawing here, this is going to be VL minus VC. Okay, so in VL is bigger and VC is smaller. That's why I got this vector. Now, after doing this, now you can see here, dear children. So what you can see here, now I have got two vectors here. Which are they? I mean, I have completed the parallelogram also. Look at this first vector. This is like VR, no? This is VR vector. And what is this? This is VL minus VC vector. And angle between them is 90-degree. All right. So whenever angle is 90-degree, I'm going to get one more vector here. No, so I'm going to get one resultant as diagonal. Already you have heard about this in your 11th standard parallelogram law of vector addition. This only becomes what? V naught. The value of this is V naught. I told you, no? I mean, together, all of these together are going to form V naught. That's what I have represented here. All right. Okay, anyway, moving forward. So everybody knows the formula for this resultant. So what is the formula for resultant? Okay, let me, I mean, rub this off. So resultant formula everybody knows, right? So what is the formula for resultant? That is going to be under root a square plus b square plus 2ab cos theta. Everybody knows this. Okay. Now what is the formula for this resultant now? The V naught is the resultant now. V naught is equal to under root. Tell me what is the value of A? A means VR. It is like A only. So VR square plus what is B? B is like, look at this. This is like B and this is like A. Okay. No need to write that. First, but I'm just mentioning. So that becomes VL minus VC whole square. Okay. Then plus, I mean, under root will carry forward. Okay. If it is not, I mean, this plus under root is there, no, it is inside only. Plus. Okay. Under root will be carried forward. 2 into A means again VR. Correct. B means VL minus VC. And cos theta means it is going to be cos 90-degree. No? Why? Because between A and B, what is the angle? Between A and B, angle is 90-degree. Everybody knows this, no, dear children? For example, this is vector A and this is vector B. I'm going to complete the parallelogram like this. Then I'm going to get some resultant here. This resultant, I mean, this total angle between A and B, this total angle is like theta. Then R is equal to under root A square plus B square plus 2AB cos theta. So by using this formula, I am deriving this. Okay. I hope everybody understand this formula of parallelogram law of vector addition, and by using that, I will be deriving this equation. Okay. All right. Anyway, so moving forward. So look at this. This cos 90 is a 0, right, dear children? So that's why, I mean, this old term will be becoming 0. So I'll write that. So V naught is equal to what it becomes? It becomes under root VR square plus VL minus VC whole square, then plus 0. Why? because this cos 90 itself is 0, right? So whatever this cos 90 is there, this cos 90 becomes 0. So that's why this entire term becomes 0. Then after that, you can expand this. So V naught is equal to what it will come here. You can just, put this square root. And VR means what is there, dear children? You have calculated VR means I naught into R, no? So VR means what is there? I naught into R. I naught into R whole square. All right. Plus, what is VL minus VC? VL means I naught into XL minus what is VC? I naught into XC. Then it is going to be whole square. See, I'm now substituting the values. Now everything is over. The main thing was about this vectors. So this thing is over no now about these vectors and all. So once this vectors and all it is over means we can easily carry it forward. Okay. So now it is all about expansion. It becomes V naught is equal to under root. How much it becomes? It becomes I naught R whole square means I naught square into R square. No, what it becomes? I naught square into R square plus it is of the form A minus B whole square. No, A minus B whole square means it becomes, just please tell me how much it becomes. It becomes A square, that is I naught into XL whole square plus B square. B square is I naught into XC whole square. Then minus 2AB. Under root as usual it will be continued. Minus 2AB. 2 into A means I naught into XL and B means I naught into XC. Alright, dear children. Now I'm going to have V naught is equal to under root. Look at this. How I'm going to write it here. Okay. Please have a look. Please have a close look here. So I'm going to write it as I naught square into R square plus I naught square into XL square, then plus I naught square into XC square, then minus, under root will be there, 2. Look at this I naught into I naught. I naught into I naught is I naught square, then into XL into XC. Correct? So this is how I have written here. Then after that, I'm going to write V naught is equal to, let me put it in this form. Now look at this, in all these terms, no, I naught square is common. I naught square, if you are taking common, what will remain here? R square plus XL square plus XC square minus 2XL XC. You can have a look also. Okay, see in this term, no, in the first term what is common? I naught square into R square means I naught square is there. Here also I naught square, here also I naught square, and here also I naught square. I have taken that I naught square common, and once I have taken I naught square common, I have written other things inside the bracket. Then V naught is equal to what else it becomes? I naught square means it is there in the square root. This is square and square root will get cancelled for I naught square, no, so that's why it will come out and it become I naught. And inside the bracket what remains? The thing which is remaining is R square plus XL square plus XC square minus 2XL XC. All right. Then after that V naught is equal to I naught under root. Now tell me. So it becomes what? R square plus. Now look at this equation, dear children. Whatever the equation is, look at this. It is of the form A minus B whole square. No, A is like XL, that is A square, then B square, then minus 2AB. 2 into A means XL and B means XA. I hope everybody is understanding. So already you have passed your junior classes, no? You must be getting idea. So this is going to be XL minus XC whole square. All right. Now here only I get V naught is equal to I naught into this thing. Whatever this big equation is there, no? So that itself is known as impedance. All right. Because I have formula, no? What is that formula? Voltage is equal to current into something. Okay. That's something, no? So whatever that something is there, if resistor is there, in resistance, there something becomes R. In inductor, that something becomes XL. Okay, in capacitor, that something becomes XC. But in a series RLC circuit, that something becomes impedance. So that's what Z is all about. Okay, so I have just written all these things to make you understand, how you have to make an approach. All right. All right, dear children. So I got the equation for impedance. So that's it. That's all about this. Okay. So then I'm going to write here Z is equal to under root R square plus XL minus XC whole square. Just confirm whether you have understood this derivation or not. Yes, dear children, just confirm whether you have got it or not. Yes, it's a little bit a bigger
Yes, sir.
derivation, but yes, but as if you practice this, definitely will have feel of this. Okay, that is for sure. Okay, please make a note of all these things. I hope already you must have made notes of this. This is a very important 5-mark derivation, and they will be asking this. All right, dear children. Yes, please tell me.
Yes, sir.
Okay, fine. So now I will be moving forward. Shall we do some more questions, dear children, so that you understand all these things? Shall we do some more numericals for your practice? Yes or no? Okay. So let us try to do some more numericals. So as of now, make notes of all these things. We'll look into some more numericals. Then we'll start one more new concept after getting into the numericals. Okay. All right. So let me give you a question. So take this question. That question is like this. What is that? In a series LCR circuit, in series LCR or RLC, both are same. L is equal to 10 millihenry, C is equal to 10 millifarad, and R is equal to 10 ohm. Okay, this combination is connected. This combination is connected to AC source, 220 volt, 50 hertz. 220 volt, 50 hertz. Find peak voltage drop in. Find peak voltage drop in inductor. Peak voltage drop in inductor. Okay, this is the only question which is being asked. Please do this. Quite simple, no? Yes, I think everybody is going to do this. Okay, can you do it as homework, dear children? Will you do it as homework? I mean, afterwards, will you do it? Or you want to do it now only? This is very famous question in your Karnataka board examinations. Okay, L is equal to 10 millihenry means it is going to be 10 into 10 to the power minus 3 Henry, and that is equal to 10 to the power minus 2 Henry. All right, then I have capacitance is equal to 10 millifarad, that is equal to 10 into 10 to the power minus 3 farad, that is also equal to 10 to the power minus 2 farad. 10 to the power minus 2 means you understand, no? 0.01 it is. All right, so you can write as 0.01 Henry also. Here also you can write 0.01 farad. No issues. And after that I have got some resistance that is equal to 10 ohm. Okay. Then what they're asking, find peak voltage drop. Voltage drop, if I want to find out, first of all, I want current or not. I want impedance or not. Before current, I need impedance. Okay. And what else is given? F is given as 50 hertz. Okay. Then VRMS is given as 220 volt. Correct, no? So VRMS is given as 220 volt. Let us try to find out XL first of all, because Z I want, no? To find out the Z is equal to, what is the formula? Under root R square plus XL minus XC whole square. And I want the formula for XL, no? What is the formula for XL? 2 pi FL. All right. So 2 pi FL means 2 into, you can take this pi as 3.14 into F means 50 into L means, what is the value of L? Here is L. So L is going to be 0.01. All right. So it is going to be 2 into 50 is 100. 100 into 3.14 into 0.01. So it becomes 314 into 0.01. Again, it becomes 3.14 ohm. So XL is equal to 3.14 ohm. I hope it is clear. All right. Then after that, we are going to find out Xc. Xc is equal to 1 by 2 pi Fc. So it is going to be 1 divided by 2 into pi means 3.14 into F is 50 into C. What is the value of C? C is going to be, look at this, 0.01. All right, 0.01. So it is going to be 1 divided by 314 into 0.01. So that is going to be 1 divided by 3.14. 1 divided by 3.14, easily you can do it. So almost it becomes 0.33, I guess, or maybe 0.32. You can do this. 1 divided by 3.14. Can somebody tell me what is 1 divided by 3.14?
0.318, sir.
0.318. Okay, 0.318 ohm. So whatever you get, so that is finalized. So after that, you can find out Z. Z is equal to, you have the formula, no? What is that? R square plus XL minus XC whole square. R square means it is going to be 10 square plus XL means it is going to be 3.14 minus XC is going to be 0.318 and whole square. Okay. Now under root 10 square means 100 plus. Please tell me what is 3.14 minus 0.318?
2.822.
2.822 whole square. Now under root 100 plus, please tell me what is 2.822 into 2.822? 7.96. Correct?
9684.
Okay, it's okay. 7.96 is fine, no? Don't confuse your with too much data. With the two places are more than enough. 7.96 is fine, no? 107 plus 9, 107.96. Please tell me what is the square root of 107.96?
10.39.
10.39 ohm. So this is going to be 10.39 ohm. Okay. So it's quite lengthy, but it's a simple problem, but a little bit lengthy. Okay. But what they're asking, that's also important. No, they're asking for what? They're asking for peak voltage drop in inductor. Okay. In inductor, they're asking peak voltage drop. So I mean peak current. I need peak current, but RMS voltage is given. Let us find out RMS current first of all. RMS current is equal to VRMS divided by Z. What is VRMS? VRMS is 220, I guess. Correct, no? VRMS is 220, and that is divided by Z means what is the value of Z? 10.39. Please tell me what is the value of IRMS? Yes?
21.17.
21.17.
17 ampere, but I don't want IRMS. IRMS means it is going to be I naught by root 2. I naught by root 2 is equal to 21.17. Okay, so I naught is equal to, it becomes 21.17 into root 2. Can somebody tell me what is the value of I naught? Yes, you know, right? How to do it?
29.84.
29.63.
29.6. So whatever value you get, you have to do it. Okay. So with calculator, how you have to type? You have to type 21.17, then into mark, then square root you have to type, then 2 you have to type. So like that you have to type it. I hope everybody knows it. So please tell me, someone tell me your answer. 20?
9.8.
21.84. Okay, 29.84 ampere. Whatever you get, you have to write that. So this is the peak current. So now what I want peak voltage drop in inductor. So I want voltage drop in inductor that to peak. Correct, no? So this is how we are supposed to write, no, dear children? So what is the meaning of this? V means voltage, that is for sure, and L means it is there in inductor, and not means it is there in I mean uh, I mean it is a peak voltage. That's how we write it, no, dear children? Yes or no? And that is equal to I naught into XL. Correct? Correct or not? Please confirm whether it is correct or not, whatever I have told.
Yes, sir.
Yes, sir.
Okay. So it is going to be I naught is going to be 29.84 ampere into XL is going to be 0.01. Okay, so that's why I'm going to get it as 0.2984 volt. So approximately you can say it as 0.3 volt. So peak voltage drop in inductor. Peak voltage drop in inductor is going to be 0.3 volt. This is the answer. Clear, dear children? Yes. Clear or not?
Yes, sir.
Yes. So this is how you have to carry forward all these calculations. Okay, this derivation also you have seen. Now there is one more situation, dear children. There is something called resonance. Okay. So what is the meaning of resonance? Resonance means at resonance what happens? No, this XL and XC become equal to each other. Okay. At resonance what happens? XL, whatever inductive, XL means what? Everybody knows this. No, this name you should not forget. Okay. Inductive reactance. XL means inductive reactance and XC means capacitive reactance. So whatever inductive reactance and capacitive reactance are there, they become equal to each other. Okay, then only it is called as resonance. Now at resonance, what happens to this impedance? Look at this at resonance. Impedance is equal to, what is the formula? Under root R square plus XL minus XC whole square. This is the impedance formula. At resonance, what happens? Tell me. At resonance, XL is equal to XC or not? At resonance we get this, so that's why we get it as under root z is equal to under root R square. So XL minus XC means, and both are equal means I can write XL minus XL whole square, no? Otherwise I can write XC minus XC whole square, no? Because XL minus XC is there and I have got XL and XC are equal, correct? So that's why, I mean, whatever this thing is there, no? So this can be written as XL minus XL whole square. That means it becomes 0. So that is like Z is equal to what is remaining? Under root R square. So this square and square root get cancelled. And Z is equal to what it becomes? It becomes R. So that means whatever impedance is there, that impedance is converted into what, dear children? That impedance is nothing but resistance only. So what I'm trying to say here is at impedance, I mean, at resonance, whenever there is a resonance condition, at resonance, series RLC circuit series RLC circuit is converted to resistive circuit. Okay, resistive circuit, because only resistance is remaining, no? Resonance means, did you understand, dear children? Resonance means simple condition. What is that condition? That condition is like inductive reactance and capacitive reactance both will become equal to each other. All right, so if both are becoming equal means, so they will subtract from each other and they become 0. So that's why only R is remaining. All right, dear children. So that's why, see, I mean, what is the meaning of this? For example, if I write only a circuit like this, so what is this? This circuit is called which circuit? This circuit is called as resistive circuit. Okay, because only resistance is there. Okay, if I write any circuit like this, now what is this? What is the name of this circuit? This circuit is inductive circuit. Why it is called as inductive circuit? Because only inductance is there. Now if I write something like this, now what is this? You can easily tell this is called as capacitive circuit. Okay, this is called capacitive circuit because only capacitance is there. Now if I write like this, now what kind of circuit it is? Tell me. So it is R and this is L, so this becomes series RL circuit. Only R and L elements are there, C element is not there. All right, so if I write something like this, L and C, okay, so now what is the name of this circuit? Please tell me quickly. So it becomes
Series LC.
series
Series
LC
LC
circuit.
circuit.
Okay, if I write something like this, now if I write something like this, now tell me what is the name of this circuit? This is parallel LC circuit, no? Yes or no? This circuit will also come to you. This is parallel LC circuit. Okay, L and C are in parallel. So like that, I mean, series RLC circuit is there, no? Series RLC circuit I have got, and it is connected to AC. Okay, V is equal to V naught sine omega t. All that it is there, and R, L, and C, everything is there. Now, whenever this circuit is, I mean, it is reaching the resonance condition. At resonance, okay, if it has gone to resonance means what will happen, dear children? So these L and C will be cancelling each other. Okay, they will cancel each other because at resonance, what I told you, XL is equal to XC. I mean, both of these, no, they will be cancelling each other, their effect will be cancelled with each other. So that's why at resonance, so if they get cancelled, what remains here? Only resistance remains or not? Only resistance remains, and this is connected to, I mean, they will be there physically, they will be there, but their effect will be removed. All right, so now what circuit it has been converted into? Don't you think it has converted into resistive circuit? Yes, dear children, are you understanding my point? Okay, what is the value of, one more question, what is the value of impedance? What is the value of impedance of series RLC circuit? Series RLC circuit at resonance. Okay, at resonance, what is the value of impedance of series RLC circuit at resonance? Just write impedance value will be equal to resistance. That's it. Did you understand this question, dear children? Did you understand?
Yes, sir.
Okay. Now, I mean, the 1 mark or 2 mark question can be asked like this. In RLC circuit, in series RLC circuit, in series RLC circuit, R is equal to 10 ohm, L is equal to 10 Henry, and C is equal to 10 farad. It is connected, it is connected to AC source of V is equal to 100 sine 100t. Okay, find find peak current, find peak current in the circuit, in the circuit at resonance, at resonance. Okay, they're asking you to find the peak current in the circuit at resonance. Okay, resonance condition. Now tell me, R is equal to 10 ohm is there, L is equal to 10 Henry is there, and C is equal to 10 farad is there. That is there for sure. Okay, and I have got V naught is equal to 100 volt and omega is equal to 100 radian per second. This is there, I am not denying that, but they're asking at resonance, no? Don't you think at resonance Z is equal to R? Tell me, dear children. No need to find Z now. You are not supposed to find Z by using the formula under root R square plus XL minus XC whole square and all. This is not required now. Why it is not required? Tell me. Because already we got to know they have given one condition there. What is that condition? That condition is like a resonance. At resonance. So at resonance, Z is equal to R. That's it. Now, what is the formula for peak current? So I naught is equal to V naught divided by Z. Everybody knows this. You know this or not? Yes, dear children, please confirm whether you know this or not.
Yes,
See, V
sir.
naught is equal to, yes, okay, fine. So you know this. Good. So I naught is equal to V naught is going to be 100 volt and Z is going to be R. R means what? 10 ohm only. So it is going to be 10. So 0 get cancelled. I'm going to get I naught is equal to 10 ampere. That's it. Is it clear, dear children? Is it clear?
Yes, sir.
Yes,
Yes.
sir.
Okay. So 1 mark and 2 mark question can be, this can be asked for 2 mark also and maybe 1 mark also. Always remember at resonance Z is equal to R. Okay. Z is going to become equal to R. If you remember that, then things will be quite simple for you. All right. Fine then. So like this, I mean, there will be many models of questions. Okay. There are many models are there. As we proceed into the class, I mean, today you try to understand these things only. I mean, as in starting these, I mean, 3 classes or 4 classes, if you understood about the derivation and if you got to know about what is the resonance and all, that is more than enough. Okay. Now, if they ask you one question, what happens to series RLC circuit? Series RLC circuit at resonance. At resonance. Okay. So what you are supposed to write here? You are supposed to write at resonance. At resonance, series RLC circuit, is converted to resistive circuit. That is what you have to write. Is it clear, dear children?
Yes,
Yes.
sir.
Confirm whether it is clear or not.
Yes, sir.
Now look at that. There is one more thing called as resonant frequency, or it is also called as resonance frequency. Resonant frequency is also called, or we also called it as resonance. Resonance frequency or resonant frequency, both are same things. So what is this? Look at this. I mean, at resonance, we have told you, no? I mean, I have told you. At resonance, I have told you what I have told you. XL is equal to XC. I have told you, no? So XL is equal to XC means what is the formula for XL? XL is omega L. What about XC? XC is 1 by omega C. Correct, no? Is it correct, dear children? Now, if you send this omega this side and L this side, okay? So I hope you are understanding what I'm saying. So what it becomes? It becomes omega square is equal to 1 by LC. So now what will the value of omega? Omega is equal to under root 1 by LC. So omega is equal to under root 1 by LC means I can write it as 1 by root LC also. So whatever frequency I have got here, no? So this frequency itself is known as resonant frequency, and that is represented by omega naught. Omega naught is equal to 1 by root LC. So this value, whatever I have got here, no? So this is called as angular resonant frequency. What is this, dear children? This is omega only. I'm not saying it is not omega, but special name is given, that is omega naught. Okay. Omega naught means what is this? Resonant angular resonant frequency it is. All right. Angular resonant frequency. Then moving forward, I mean, you know the formula for omega naught, no? So omega means it is 2 pi f, no? 2 pi f. But naught is there, that's why f naught. F naught is equal to, it becomes 1 by root LC. All right. So what is the formula for this f naught? F naught is equal to 1 by 2 pi under root LC. Now, what is the meaning of this f naught? This f naught means that is linear resonant frequency. What is this? Linear resonant frequency. If somebody is asking you to find the linear resonant frequency by giving L and C, you should be able to find out. And by giving L and C, if somebody is asking you angular resonant frequency, that also you should be able to find out. Is it clear? Did you understand about resonant frequency, dear children?
Yes, sir.
Yes, angular resonant frequency and linear resonant frequency, both you should be, clear about. Okay. In the question, they may ask you so many things. Okay. Last problem I'm giving you to give you practice of this thing. I'm going to end this impedance thing. Then I'm going to move for further things of transformer and some other derivations. Please do this. In series RLC circuit, in series, this is homework. Okay, this is the homework immediately after the class. In series RLC circuit, R is equal to 10 ohm, L is equal to 10 millihenry, and C is equal to 5 microfarad. It is connected to AC source of 100 volt comma 50 hertz, 100 volt comma 50 hertz. Find A peak current, then B RMS current, then C peak current at resonance. Try to look at this. If you solve these questions, then you'll be perfect. Peak current at resonance and voltage drop in resistor. If they're asking voltage or just mentioning voltage drop means what they're asking for RMS. Please remember this. If they're not mentioning any voltage means that is RMS. If they're mentioning peak voltage drop, then we can understand that. Peak voltage drop in capacitor. Here they have mentioned what they have mentioned, dear children. Here they have mentioned just voltage drop, no? So what is the meaning of this? This voltage means this is RMS. Is it clear? Okay. So then moving forward, you can find out RMS voltage drop in inductor. Okay. Then G, you can find out linear resonant frequency. Linear resonant frequency. Okay. Can you do all these things, dear children? Will you do them? Yes or no? Will you solve these questions?
Yes, sir.
Okay. All right, dear children. Thank you very much for joining the class. Have a good day and bye bye.
Bye, sir.
Bye everyone. Bye everyone.
Bye,
Bye,
sir.
sir. Bye, sir. Thank you, sir.
Bye. Bye everyone. Bye everyone.